This conference will now be recorded.
Okay, so today we are going to start with the basics of Java and JVM. Um, mainly when we move from performance testing to performance engineering, right? One of the one of the struggle that we will have it in the initial days is talking to the developers and communicating the problems, bottlenecks in such a way that they don't put the blame on our scripts or our data, right? Normally, even with your testing itself, when we go and say that response time is high, or if there are so many errors, most of the time they will try to put the blame on our script or environment or test data to get some time wherein they can go and analyze something and have the fix ready. Right now, with engineering, we are going to go one step um, beyond your testing, and we are going to go and say you have a problem and there is a response time problem or a memory problem, and this problem is pointing out to you this particular class or a method, right? um, so when we are going to talk about these things, we have to feel confident enough to go and talk to the developers in their own language. Otherwise they can easily dominate us, right? So when we begin this engineering, we always going to have this kind of mind block whether the team will listen to us. If I'm going to go and say something, will it be wrong? Will they ask question? Will they pinpoint some problem in our end, right? Those are all the things that will go on in our mind, for me, for everybody, when we have started this engineering journey, right? So to break that thing, you first of all, you have to be a little bit confident when you go to speak about something. For that, you should know some basics about certain things about Java, about JVM. We want to talk about these terminologies, right? You have a problem with this class, you're going to have a problem with this method, you have a problem with this object. All these things you're going to communicate to the developer. So you should know what it is. It should not be a complete black box. We are not going to go and do hardcore programming, understanding each and everything. No, just the basic things, that is more than enough for us to start your engineering journey. And as you move along, as you gain experience, you will eventually learn a lot of other things as well. But to get started, we thought you should have this bare minimum knowledge about certain things about Java and JVM. Okay, so when it comes to Java programming, right? An enterprise application can have n number of programs, right? But if you take any program, there are going to be certain template that is going to get followed. Okay, so in probably when we get a time on Monday, we'll also try to go and create few programs. I also have a video which I will share it with you, which will talk about um, how to create your Java programs, doing some of the important algorithms like connecting to your database, making an HTTP connection and all. I have a video which I will share it with you, and we'll also go and create some programs on Monday. Okay, so be it a one program or n number of programs, it is going to have a kind of a skeleton. When I say skeleton, right? If you guys have worked on LoadRunner, a LoadRunner is going to have a skeleton, right? It is going to have a init, it is going to have an action, it is going to have a user end, and you're going to have start transactions, end transactions, all these functions, right? Any LoadRunner is going to have these template. Similarly, when it comes to Java program, you're going to have this template in any program. It is going to have a class, it is going to have a method, it is going to have a package, it is going to have an import, and there is also concept of object. Okay, so let me go one by one and explain what is this. A class is nothing but a program. If you create a program, a Java program, say to add two numbers. Okay, so your program, you put your logic in that, for addition of two numbers. That is called a program. That is called as a Java program. That is called as a class. A class is nothing but a program. You save it as .java, say addition.java. You save that as a your program, and when you compile it, it will become a class, addition.class. So a compiled program is your class. Okay, so inside your class you are going to have multiple things. So to do addition, you would need what? You need to store something temporarily, first number and second number, right? So you declare some variables. It can be an integer, it could be a character, it could be a string, it could be array, anything. So a program is going to have a data, and then your actual addition, right? The operation that is going to be there inside your method. So method, a class will have two things. One, it will have a variables declared, and then you're going to have a actual calculation, actual algorithm written inside a method. So one class file can have multiple data declarations, and it can have multiple methods. Say for example, if you wanted to do an addition and then save that in a file, or send that data to a database, then which means it can have three methods. It can have one method for addition, one method for writing into a file, one method for sending it to a DB. So a class file, inside a class file, you're going to have data declarations like int A, int B, name, string, name, character. All these data types are going to be there in your class file. It is going to have multiple methods. Method is nothing but the actual operation, actual algorithm is going to be inside a method. Okay, and then um, um, in a project, there can be multiple class files like this, right? One class file for addition, one for login, one for search, one for subtraction. There could be multiple class files. So a package is nothing but a grouping of all these multiple class files. Okay, and um, import. So this import is nothing but uh, not necessarily you will create all the algorithm by yourself. There might be some other people who would have created something which you can reuse it, right? So you can import their package. It could be a package created by your team, your enterprise, or you can download it from the internet also, right? Lot of jar files, lot of reusable files are going to be there in the internet, which you're going to import it. Okay, so import is nothing but when you wanted to reuse other programs, other packages, other teams packages, you will have this called something called import. Okay, so a Java program is going to have a class, is going inside the class you're going to have data types, data declaration for variables. You're going to have methods. A group of class files is got called package, and you can import the other teams packages or the package from the internet. Okay, so this is the skeleton. If you take any application, any program, it could be a very small program that you will use it for your learning, or it could be for your enterprise, in your projects. Everything is going to follow this skeleton. We are going to, when you're going to do a response time analysis, when you're going to do a leak analysis, right? You are going to find out, okay, response time is I in this class, in this method. That is how we are going to analyze and provide the your observations. So it is important to understand how this is structured. Okay, now there's something called object which I missed it. Okay, Probably some of you are from automation background, right? If you use a Selenium, this might not be new to you. Because Selenium itself is a Java, and all everything what you do inside your Selenium is going to be a class file. You're going to have objects. You're going to have methods. Probably this might not be new to you. Okay, so this object. Okay, um, so there are many ways people explain this object. Java being an object-oriented program, right? This word object has been, you can explain it in different ways. I'll try to put it very simple, though it might not be an accurate way of explaining it, but I'll just try to keep it simple. Okay, so you are going to use Amazon.com, and I'm going to use Amazon.com. Okay, and you might be entering into an site, and then you will be looking for a laptop, and you need one a Dell laptop, and I'm logging in. I'm looking for a probably a mobile, right? One Samsung and one maybe a two Samsung mobile. Okay, so and you might be clicking something called uh, uh, calculate the pricing, or you want to know the price of that particular laptop, and even I wanted to know the price of this two Samsung mobile. Okay, so when you go and click something, when I go and to click something, it is going to go to your server, and there might be a class file to provide the price, right? So there will be something called price.java, price.class, and in that price.class you are going to have methods which is going to receive your input. There is going to be some data types declared, like integer or character, to receive your product, to receive your quantity. So for you, the program will receive something called product equal to laptop and quantity as one. For me, it is product equal to mobile, quantity as two. Okay. So what happens is uh, when when um, a request is going to come from you, when a request is going to come for me, when it goes to go get into a class, okay, um, there'll be something called object that will be created during a runtime for a price dot class. Okay, so there's only one thing called one class file called price. Okay, but it has to handle data for it has to handle the request for you, it has to handle the request for me. So what happens is, during a runtime there will be something called object that will be created for this price dot class file. One object for you, one object for me. Okay, so the class called price, for that class file, two objects will be created at that time, one for you, one for me, and that object will, whatever data you declared in the program, right? So for the object is nothing but a duplication of a class file. So for you, for that, for your object, your quantity will be one, product is laptop. For the object for me, it is going to be a quantity is equal to two, mobile product equal to Samsung mobile, and then it is going to go and execute that method. It will find out the price from database. It will return the data to you for the price of laptop. For me, the price of the two Samsung mobile device. And then once it is done, once the requests are completed, these objects will get deleted. Okay, that is where this garbage collection all will come into picture, but let's not worry about that. Assume that there are 100 people who are accessing your Amazon.com, looking for price, looking for cart, looking for order summary. For every request, as many objects will be created corresponding to that particular request and class file. Okay, if you see this diagram in that slide, right, there is something called a class called student. Okay, so think that there's a school where people come to enroll themselves for the school, for their class. Okay, they are trying to come and enroll into the batch. Okay, while they register it, they give name, age, color, all these details they give it. So there's going to be only one class file called student. So when 10 people are going to register, 10 objects are going to get created. First object is going to have age equal to 12, color equal to fair, and then it says John can eat, John can drink, John can run fast. So that details will be received by this object, and the execution will happen to save the data in the database. Okay, so the object is a duplicate or template of a class file. N number of objects will be created and destroyed. Okay, so that is a definition of the object. So what you will see is, when we are going to do a leak analysis, we are going to do take a heap dump, right? We are going to look into the objects. How many objects are, we will not go and look into how many objects are created, but every object is going to occupy memory. That's why we are concerned. Otherwise, we will not concern about object. Every object is going to consume 1 MB or 2 MB or 500 KB or 10 KB. Okay, so when these objects are created, it is going to have take some heap. Or we'll talk about what is the heap and what is the memory and all, but it is going to occupy some memory. So if the objects are not getting deleted, your memory will keep on be accumulating. It will see, the idea is, during your 24/7 application is running, you will have multiple objects getting created. At some point of time, your 4 GB RAM or 4 GB heap will not be enough. So objects should get created. It should get also get deleted, so that other new objects can keep getting created, right? Otherwise, if the objects will not go out after 3 hours, 4 hours, 5 hours, your 4 GB heap will be occupied. 4 GB memory will be occupied. So while you do a leak analysis, while we do your monitoring your heap analysis, you will keep hearing about objects. When you do responsive analysis, you will keep hearing about class, your methods. All these things is what we'll go and report. So you should at least have a visualization or better idea about, okay, in Java program, you're going to have class, you're going to have method, and this is how the object is getting created. That kind of your hands-on, that kind of visualization you should have it, so that when you go and talk about that, it will be easy for you to go and talk. Okay, we'll definitely go at least open the Eclipse and then create a program, and then add few files, multiple class files, and see how from one class file other class files can be called, or at least one program. We'll do it on Monday. What I'll do is, I'll ask the team to share you a video as well, where I would have given some instruction about how to create this class file, how to create this method, how to call one class from other class file. If when you get time over the weekend, just look into it. It will be really interesting video. And Monday I'll also try to do definitely one hands-on program, so that it will be more comfortable for you to repeat that in your laptop. Okay, and then the data type. Okay, data, whatever you're going to declare in the program. You have integer, boolean, byte, strings. All these things are all kind of data types. Let's not worry about what it is, each and every data type. Classification wise, there's a primitive, there's a non-primitive. Primitive one are, it is going to start with a small letter, I, B, C, B, all small characters. Non-primitive will always start with a uppercase letters. Strings, arrays, classes, right? So it is not too important for us whether it is going to start with a small letter or caps, but from a memory perspective, the way JVM, we'll talk about JVM also, what is JVM, the way Java or JVM handles these primitive and non-primitive, that is why we need to understand these two words, primitive and non-primitive. Okay, there is something called stack and heap. We'll talk about stack and heap today or Monday. Okay, so by nature, your primitive data types are very, very small in size. Okay, it will occupy very lesser memory space. Okay, so all these things will be stored in the memory called stack. All your non-primitive will be stored in the heap. Don't worry about that. We are going to talk about lot about that in coming days. Just two type of data type: primitive and non-primitive. Primitive with primitive is nothing but data declared with the small letters, and non-primitive will have a uppercase, lowercase, and uppercase. Okay, primitive will get stored in stack. Non-primitive will get stored in heap. Don't worry about that. We are going to talk about that in detail as we move along. Okay, fine. So this is a very basic skeleton about any Java program. Okay, fine. Next basic thing is your JDK, JVM, JRE. Okay, so you create a Java program. It has to run somewhere, right? So it needs a runtime environment. It needs an environment where you can execute your Java. Okay, the main reason it needs a runtime environment is you might have heard this, right? Java is a OS independent programming language, which means you can create a program in your Windows machine, and then you can run it in the Mac, you can run it in the Linux, you can run it in any of the other OS. The reason it could be able to do is it has a runtime environment. This JRE, it is going to be installed in your OS, and this JRE, there are JRE for Mac, there is a JRE for Windows, there is a JRE for Linux. So irrespective of these OS, there is a respective JREs that are going to be installed in these OS, and JRE will take care of running the Java program. So your Java is not going to run directly in your OS. It is going to have its own Java environment, runtime environment, because of which there is a JRE for Linux, JRE for Windows, Mac, so that you don't need to worry about it. You create a Java program in Windows and go to Linux, install Java for Linux, install Java for Mac, and then run this Java program. That JRE will take care of executing your Java program. Okay, so you have three things: JDK, JVM, JRE. Okay, JDK is nothing but a Java development kit. So if you are a programmer, if you are a application developer, you would need JDK so that you can create programs, you can compile programs, you can debug programs. So JDK is a combination of your JRE and your compilers, debuggers. If you are not a developer, if you're just going to run an application, if you're just going to deploy an application, right, then you just need a JRE. You just need a runtime environment. Somebody has created a program. They have given you, see for example, Jmeter, right? Jmeter is a Java program. If by itself, it's a Java package. Somebody has created Jmeter, and they are giving to you. So to open Jmeter, you no need JDK. You just need a Java in your machine. You just need a JRE in a machine. Okay. So difference between these things are JDK is going to have JRE plus compiler debugger for you to create a programs. JRE is nothing but a Java runtime environment, which will have a JVM, Java virtual machine. Virtual machine is nothing but uh, um, uh, a virtual processor which is going to execute your program, which is going to um, have its own memory, its own thread through which it is going to execute a program. Okay, so JRE will have JVM plus some class libraries. I'll show it in the directory. It will be more easy for you to understand. End of the day, it's all when you install Java. Okay, when you install Java, I'll go to the Java folder. Okay, program files, Java. So you're going to have, say, JDK. Inside JDK, you're going to have all these files, bin, include, JRE, legal, library, all these things. If you go inside JRE, inside bin, you will have, if you go inside server, you have something called JVM.dll. Okay, so in JDK, in JRE, you have something called JVM. Okay, so if you have installed Java in Linux, instead of JVM.dll, you will have Linux specific JVM. Similarly, in Mac, if you go to JRE bin server, you will have Mac specific JVM. Okay, so and then you go back and then go to the bin. You will have all the say Java C. There are a lot of debugging tools also, which we'll use it for performance. JStat, JStack, okay, JVM, JPS, JMap. A lot of debugging tools will be available part of the JDK. Okay, so you don't need to worry about really know about what is going to be inside that. For you to develop it, say for example, if you wanted to download the application which we are going to use it for our practice, right? You're going to have Eclipse. You're going to open the code. Then, if you want to do all these things, you need a JRE. Or if you're not going to do any development work, if you're just going to install the e-library app in Tomcat, then you just need a Java. Okay, so you download the full JDK kit. That should be good enough for you to in your laptop. So if you don't have a Java in your machine, download the latest Java or download Java 8 or Java 11. Anything is okay. Okay. Most of the tool softwares are going to be compatible with Java 11 or Java 8. You go and download the Java 11 or Java 8, install it in your laptop. Okay. Once you download the Java, okay, downloading Java installing is very, just click, it will get installed. You don't need to do anything at all. Okay. Once you install the Java, you need to go to the open the command prompt. We open the command prompt. You need to set the environment variables. Okay. Once you install Java, right, your machine should know where the Java is installed. Okay. So you can go to command prompt, type Java-version. Okay. It will say the version which you have installed. If the environment variables is not installed, if not configured, or if it is not configured properly, okay, then you will Java-version will not work. You will not be able to open any of your Java-based application, Eclipse or Tomcat or Jmeter, any Java-based application, you will not be able to open. Okay, so you go to this system properties, go to the environmental variables, okay, and then in the system variable, okay, you need to set Java, you need to set Java home. Okay, so go click new and then type Java and then provide your JDK path. Okay, still bin. If you go to this, okay, since I've opened it, it's not opening the folder anyway. So just note down this. Where are you install the Java, right? For the variable called Java, you will provide the value as C program files Java JDK /bin, and there's something called Java Om. You need to set Java Om, and that will be till the JDK path. Okay, so you set Java and set Java Om. Two things you need to set it in your environmental variable. Go to the system property, advanced environment variable, and then in the environment variable you will create two variables, Java and Java home. And similarly, there's something called path. Open the path will be already there. Open the path, and here again you go and add a new entry and add Java JDK bin. Okay, so do three things. So you have to add Java home, and then you need to update the path also with the this particular directory. Once you do all these things, you should be able to use any Java application, or you will be able to open the Eclipse, import the project, create a WAR files, deploy the WAR files. You can use all the monitoring tools, everything. So this is the bare prerequisite. You should do it in your laptop. Download the Java, install the Java, and set up your environmental variables. Okay. I'll just take a pause here. Any questions, guys, you have?
Satish, I got one question.
Yeah, please go ahead.
Okay, you said leak analysis. Did I hear it properly? What is leak analysis?
No, I was mentioning about leak analysis, memory leak.
Okay, sorry. Okay, got it.
Yeah, when we are going to analyze your memory leak, right, we will be monitoring the memory, and if the memory keeps on going up and up and not coming down, then we will anticipate there is a leak, and then we will go and analyze why this memory is growing, why it is not coming down. This term is called a leak. If the memory keeps growing and doesn't comes down, then we will term it as a leak, and that analysis is what we will do it in the leak analysis.
Okay, thank you.
Okay. Fine. So I was talking about this JDK, JRE, and JVM, right? JVM is your core part. It is going to have. I was mentioning about all these things, right? It is going to have. We're going to assign the heap. We are going to assign number of threads, and a lot of our monitoring, analysis, all these things going to be about JVM only, because JVM is what it is going to store all your variables that you declare, whatever you declare, right? I was talking about primitive, non-primitive objects, whatever objects that is getting created, whatever your strings, arrays, classes, everything is going to be handled within JVM. So what happens inside JVM? JVM is the core part where your execution is going to happen, and when from say the way it happens, right? You create Java file .java, and then you compile it. It is going to be a .class. Okay, and this class file, when you're going to execute it, you're going to execute it in Eclipse, or when you execute it in Tomcat. Okay, when you execute your program, all these class file will get loaded into the JVM. Okay, so JVM, as there are 8 to 9 components. Okay, first of all, when execution starts, all the class files, all the programs has to get loaded, right? So it has something called class loader, which is going to load all the classes that you have created, or you have imported, or some of the native Java classes. Everything will get loaded. So class loader is the first component. We don't need to go inside class loader what exactly it is doing. It is none of our job, or even for developer, they will not worry about what happens in the class loader. It's a complete black box. We'll not worry about, even from performance perspective or not, we'll not even worry about it, what class loader is going to do it. Okay, class loader is just one of the component in JVM which is going to load all the classes. Okay, and then there is something called JVM memory. So as I said, we will assign certain memory for our execution, for your application. Okay, so the entire memory that is going to be used by JVM, internally again there is logically it is split into 5 different components. Okay, this memory itself is going to be split into 5 different components. Okay, you have heap, you have stacks, you have PC register, you have a native method stack, and you also have something called method area. Now it is not method area, it is meta space. Okay, each one will going to store different things, especially the heap and stack. I was mentioning about primitive and non-primitive, right? Your primitive will get stored in the stack, your non-primitive will get stored in the heap. Main reason, as I was mentioning, non-primitive is going to have a huge memory size comparatively, whereas primitive is going to just have a very small memory size. That is one of the reason, not exactly the only reason why this is classified in such a way. So for now, you just you understand that your primitive data type will get stored in the stack, your non-primitive will get stored in the heap. There is a lot more learning we will do it for stack and heap during our memory session. For basics of JVM, just now understand that there is 2 main section in JVM memory. There is your heap and stack, and heap is going to store the non-primitive like your arrays, your strings, your objects. All these things are going to get stored in heap. And out of all these 5 components, heap is a major component because it is going to occupy more space. Whatever we're going to do analysis from a memory perspective, it's going to be heap, monitoring the heap, configuring the heap, fine-tuning the heap, and then finding out problem in the heap, heap dumps, heap leak analysis. Everything is going to be around heap only. Other things are, other components are not something is going to be really a problematic area. We'll not even monitor it or fine-tune it. That's going to be of less significance. But heap is going to have a larger significance from an engineering perspective. Okay, so we'll talk a lot about heap in the coming sessions. Other areas, PC register, native method stack, metaspace, each one is going to hold something for your JVM to work. For example, PC register, right? As per definition, it is going to just keep noting down the methods or lines of code which is getting executed for every request. It's just going to it's just a entry, data entry, or just an information on what is getting executed. So nothing to do with the actual execution or or it is going to hold any variables. Nothing. A registry, as a name implies, it is just a registry of execution. Okay, not much of significance. We no need to worry about this component at all. We'll not even deal about it. We'll not even talk about it about the PC registers. Even for developers, even for performance engineer, nothing we are going to do with the PC registers. Like JVM stack, there's something called native stacks. Okay, while your JVM stack is going to hold your primitive data, native method stack will hold the data whenever your Java program is going to interact with other programs like your Python programs or your Windows programs, right? That interface or that communication related memory, that will be there in the native method stack. Okay, and again, we'll not monitor that, we'll not tune that, we will not worry about this at all. So only your heap and stack is something we will look into it in detail, and will be more significant from engineering as well. And stack also, there is only one or two problems you might face, is very rarely. So we'll look into one of the problematic area in stack as we move along with the course. But heap is the only thing which will be looking into it in detail. Okay, and then you have execution engine. Execution engine is where your code is going to get executed. Okay, within JVM, right? JVM is going to have class loader, JVM memory, and then execution engine. And this execution engine is going to have a couple of components inside that. So it is just for your basic understanding. You should know it. You have interpreter, you have GC. Okay, so interpreter is nothing but the interpreter is going to convert your byte code to your mission understandable code. Okay, so as I was saying here, right, it is from .java is what you create. It will get converted into a .class, and then when you're going to deploy this classes in Mac or Linux or Windows, okay, during the runtime, your Java code, you call it as a byte code, that will get converted into a mission understandable code, to Windows understandable code, to Linux understandable code. That is what your interpreter is going to do it. Okay, and garbage collection is one of the other important component. It's going to be part of your execution engine. Garbage collection is a set of algorithms, set of libraries that will take care of removing this unwanted or unused object. Okay, object will get created, it will be there in the heap. This garbage collection will go and remove the object once his work is over. Okay, we'll learn a lot about GC later anyway. Okay, so from execution engine point of view, you have this interpreter, you have this garbage collection, but again, all these components, right, there's something called hotspot profiler. Hotspot profiler will keep looking into the methods which is taking more time or which is frequently used, and there's a concept of JIT compilation. So instead of compiling this, right, instead of converting it into a mission code at the time of execution, it will pre-compile it and keep it ready. So hotspot profiler will know that this method is getting called more frequently, or if it is taking more time, to avoid or to reduce the time taken for the execution, it will try to pre-compile it. But all these things we will not have any controller. Will not have any compile. Will not have a control over interpreter. Will not have a control over JIT compiler. Will not have a control over the hotspot profiler. All these things and all JVMs internally will do it. Will not even monitor. Will not monitor the hotspot profiler. Or will not monitor the JIT compiler. What it does, it's all black box for us. We don't need to worry about it. But this GC component, garbage collection component, is something in our we will do something on GC, the way it has to work, what kind of GC tuning flags we can use it to optimize the memory. So we'll have separate session on GC when we go into the memory area. Okay. So from a JVM basics perspective, all we need to understand is there are multiple components. Your class loader, your memory, your execution engine, and within JVM memory, heap and stack is a very important components of JVM memory, and we'll learn a lot about heap and stack as we move forward. And execution engine, it has interpreter, it has GC, it has hotspot profiler, it has JIT compiler. Okay, so all these things, the reason I'm talking is it's all theoretical stuff, because these are all very basic concepts, terminologies. You will keep visiting all these names, terminologies while we do engineering. So you should be familiar with that. A lot of questions will come in the interview as well about JDK or JVM, environmental variables, your heap, stack, right? So you should be able to answer those, as well as when we do engineering, all these things will keep coming every session, every topic, these things will come. So that's the reason we want to spend some time on these concepts. Okay, I'll take a pass here, guys. Yeah, if you have any questions, feel free to ask.
Satish, will you be sharing this PDF document you're presenting?
These are slides.
Okay.
So this will not be shared, but anyway, the videos, right? Recorded. These things are going to be available. Only thing is these slides are something proprietary to the institute, so we'll not be able to share the slides. But in case if you want any specific data, let me know. I can probably take it and put it in a Word document, and I can send it to you. But anyway, these things are going to be available in the video as well, which means you can easily go and grab it for yourself at any point of time.
Okay, yeah, thank you.
Okay, fine. Fine, guys. We'll stop it here. We'll continue on Monday. Sorry, was there any question?
No, when we,
Okay.
hi, Satish, Kanan here. Can you hear me?
Yeah, please. Yeah, yes,
Yeah,
go ahead.
when we set this environmental variables, right? So Java home and path also you mentioned, right? So in the all the three places, are we going to give the same path? Only the JDK has to be given, or how?
Yeah. If you closely look into it, right, it's all it will look similar, but it is slightly different in the way you give it. Let me open this. You have to be very careful with that because in some places you have to give till bin. In one of the variable you have to give it before the bin. So Java you will give it till bin because in the bin only you will have java.exe. If you go to
Yes.
here, right, in the bin you will have the java.exe. So
Yes.
Java will look for where is java.exe. For that you have to give it till bin. Java home is nothing but where is the home directory. For that you will take the bin and then give it.
Okay.
Yeah, in the path as well. Again, if you go to the path, you will give it till the bin. It will look for the java.exe.
Okay. Thanks. Thank you,
Okay. So what I'll do is by today, I'll provide access to everyone who has registered for this. So over the weekend, try to download these bare minimum. You download Java and Tomcat, Eclipse. At least those things, if you can set it up in your laptop, that should be more than enough. I'll also ask the team to share that Java program video. So if you get time, just go over that. It will be interesting, useful to you. Okay. Fine, guys. We'll meet on Monday then.
Sure.
Yep.
So this
Thank you.
Eclipse version and Tomcat version, is any specific version, or yeah,
Any version is fine. It should not have a problem. But probably better try to download the Tomcat, which is there in the Google Drive, which I'm going to give it.
okay,
So
you're
that
going to provide that. Okay, fine.
yeah, yes. I'll give the access to you, and then also I'll provide a folder where all this Tomcat is available. You can try to get it installed over the weekend.
Sure. Thank you.
Yeah. Fine, yes. Thank you, and we'll meet you on Monday.
Thanks.
Eclipse also same. Eclipse